Hello, assalamualaikum everyone.
Walaikum salam, Miss. How are you, Miss?
I'm good.
Walaikum salam, mate.
How are you guys?
Alhamdulillah, thank you, Miss.
Alhamdulillah. So let's get started. Last class, we learned about Boolean algebra. We learned about equations, how to simplify them, how to solve them. Okay, this is a very important chapter. Now next, we're going to continue. We have one part left, one portion left of Boolean algebra, that is using universal. That is the topic on universal gates. Okay. So, can somebody tell me what universal gates are? Does anybody have any idea?
NAND gate and NAND gate and not.
Yeah, but what does
We can
that?
get back to the basic gates like and or not.
So here comes the question of basic gates. So what are basic gates?
And or gate, not gate.
And or not are basic gates, which means that if I give you and or not, if I give you these three gates, you can construct any circuit in this world. Okay, any possible circuit can be constructed using and or not. So these are the basic gates. Okay, so the basic gates are these are the basic gates. And what are universal gates? Universal gate means there are two types of universal gates, NAND as well as NOR. So with NAND gate, you can construct any circuit. That means if I give you a lot of NAND gates, using only NAND gates, you can construct any circuit in this world. Okay? So this means that if you can construct AND or NOT using NAND gate, then you can construct any circuit. So using NAND, I can make AND, using NAND, I can make OR, using NAND, can make NOT. This is the reason why if I give you a lot of NAND gates, you can construct any circuit. You will not need any other gates, because any other gate that you need can be constructed using NAND. So one of the universal gates is NAND and the other universal gate is NOR. If I give you a lot of NOR gates, you don't need any other gates. You can construct any circuit using only NOR. Okay, so this is the difference between universal gates. A difference between universal gate and basic gates. Is this clear, everyone? If anybody doesn't have a problem, I'll move on to the next section. So first, so in today's lecture, we're going to learn about NAND only. NOR you have to learn by yourself. Okay, so I'm just going to show you how do we construct circuits using NAND. So when you're using NAND, first let's learn how to use NAND to make OR gate. Okay, so typically, how many input does OR gates have?
Two input.
Sorry, not OR gate. First we're going to learn NOT gate. Okay, first we're going to learn NOT gate. So how many input does NOT gates have?
One.
One input,
Two.
right? Not gates, not gates. NOT gate, how many input?
One.
One input and it has one output, right? So if I put A here, the output will be A bar. This is how NOT gates work. And how does NAND gates work? So if I have a NAND gate, right, if I give, let's say if I give X and if I give Y, then the output will be X and Y not. Okay? Is this clear, guys?
Yes, miss.
Okay. Now let's see if I have a NAND gate. How can I turn this into a NOT gate such that I'll insert A here and as an output I'll get A bar. So what we can do is we will short both the inputs and put A here. Okay. So A will go through this input because I've shorted it, and A will also go through this input. So the output will be AND of both inputs, and both inputs are taking A. So A and A whole bar. Okay, so A and A is A, so it's going to be A bar. So this block, sorry. So now this block works like a NOT gate. Okay, so I've used a NAND gate to construct a NOT gate. Is this clear, everyone?
Yes, miss.
Okay, now can you try to construct AND gate using NAND gate? Using NAND? Okay, so to construct an AND gate with NAND, let's first see. So if you have a NAND gate, okay, if I have a NAND gate, I have input A. If I give A and B as input, what do I get? I get A and B bar, right? Now if I just want A and B, I need to remove this bar, right? So if I pass this through a NOT gate, then it will become A and B, right? Because A and B double bar will be A and B. Is this clear?
Yes, miss.
Okay, but I want to construct AND gate using only NAND. So I need to replace this NOT gate. How do I replace the NOT gate with NAND? By this, right? Is my point clear? I want to build AND gate using only NAND. So I already used NAND here. Now the NOT part needs to be replaced with NAND. So how do I construct a NOT gate using NAND? I will simply pass this input in a NAND gate. So I'll have a NAND gate here. And if I have to NOT something, I'll simply pass that input, that as both the inputs of a NAND gate. Okay, so this is a NAND gate. So here I have A and B whole bar, and to NOT it, I'm passing it through both the inputs of a NAND gate, because if I pass something as both the inputs, it comes out as a NOT of that input. So here I'm passing A and B bar, and as an output I'm getting A and B. Is this clear? So first, to form an AND gate, first you do NAND, and then you NOT it. So if you NOT a NAND output, you get AND. Is this clear, guys?
Yes, miss.
Okay, so this is how you construct a NOT gate and an AND gate using NAND. Now the next part is we're going to construct OR gate. Okay, we're going to construct OR gate using NAND. Can you try? So let me give you a hint. So if I have a NAND gate, okay, and I pass from here, if I pass A, B, then what output do I get? As output I get A, B, whole bar, right? Which is equals to A bar plus B bar, right? Guys, do we understand this?
Yes, miss.
Okay, but I don't want A bar plus B bar. I want A plus B, right? For OR,
Yeah.
if I pass, I want the output to be A plus B. So if I want A plus B, if I pass A bar and B bar, then what will I get? A bar and B bar. Let me rub this off, it's a bit congested. So if I pass A bar and B bar, then I'll get A bar and B bar whole bar, right? A bar and B bar. If I NAND it, then A bar and B bar and then whole bar. And if I take the brackets away, then this will become A plus B. Is this much clear?
Yes, miss.
Okay. So if I pass A bar and B bar through a NAND gate, then I will get A plus B, right? Is this clear?
Yes, miss.
Okay, if this is clear, then see that here I have to pass A bar, right? So as in I want that, I just want to give A as well as B as input, and I want A plus B as an output. So through the NAND gate, I need to pass A bar, right? But I have A. So how do I make A bar? Can somebody tell me? How do I make A as A bar?
Not gate.
Right, NOT gate, right? But I'll have to use the NOT gate. I'll have to use NAND as the NOT gate. So how do I do this?
By shorting an AND gate.
Right, by shorting the NAND gate. So if I pass A through both the inputs of a NAND gate, then I'll get A bar. And if I pass B through both the ends of a NAND gate, then I'll get B bar. So first I'll make A bar, then I'll make B bar, and then I'll pass the A bar and B bar through the NAND gate, and I'll get A plus B, because here I'm getting A bar and B bar, and if I NAND them, A bar NAND B bar is A plus B. So is this clear how we constructed OR gate, AND gate, as well as NAND gate using only OR and NOT, the three basic gates using only NAND gate? Is this clear?
Yes, miss.
Okay, so your homework will be, you have to construct the basic gates but using only NOR gates. Okay, I've shown you OR gate, but you have to do NAND gate. Okay, now your next task is, you need to construct this circuit A plus B bar C, A plus B C bar, but using only NAND gate. Okay, using only NAND gate, you have to use A plus B C bar. Using only NAND gate, you need to construct this circuit. So can you try? So for this, what you first do is, you first draw the circuit using only the basic gate. So it's going to be A plus, right? B into C bar. So I have A, B and C. So first I'll make C bar. So first I will make C bar. Okay. Then I will AND it with B. I'll AND it with B. And then I will OR it. I will OR it with A. Is this much clear? I just simply drew the circuit using basic gates. Is this much clear? Guys, is this much clear?
Yes, miss.
Okay,
Yes.
so here I got a plus bc bar, but my instruction was that I need to construct this using only NAND gate. Okay, using only NAND. Okay, so how do I do it? First, I will replace all the NOT gates. So how do we make NOT with NAND? Guys, how do you make NOT with NAND? Simply short both the inputs, right? So I'll short both the inputs, and now this becomes a NOT gate. Okay, so this becomes C bar. Okay, then I'll see if there are any other NOT gates. I will replace that. Okay, after NOT, I will replace all the AND gates with NAND. So how do I construct AND gate using NAND?
By two NAND gates.
Right. First we do NAND, and then we do NOT, right? So
Yes, miss.
first we do NAND, and then NAND, and then NOT. Okay, NAND and then NOT. Okay, so you don't have to think much. Simply just, we have already drawn the basic gates before, so just know how to draw AND gate with NAND. So AND, for AND, first we do NAND, then we do NOT. Okay, all right. And next, what do we do? This is how it looks like. Replace the OR gate. How do we do the OR gate?
Two NOT gate, one NAND gate.
Right. Two inputs, both the inputs should first be NOT gate, then a NAND gate. Okay, so AND gates are, OR gates are the biggest. Okay, so I usually do that at the last. So if I have to OR two inputs, first what do I do? If I have to OR two inputs, first I will NOT them. So first I will NOT them using NAND. So this I have NOT them. Okay, they look really ugly, but I hope you understand these are all NAND gates. Okay, so first I will NOT them, and after doing NOT, then I will NAND them. Okay, so you don't have to trace this circuit, you don't have to do anything. Simply just replace the basic gates with what we've learned as a part of the construction. Okay, and if you trace this, you will see that if you use Boolean simplification, you will get a plus b c bar, but you don't have to do it. Okay, just simply draw it with basic gates and then replace the basic gates using NAND. So this was for a plus b c bar. Now as your homework, what you have to do is you need to you do the same thing using NOR gate. Okay, first try creating OR gate, NAND gate, NOR and OR gate using only NOR, and then try to construct this circuit using only NOR. Okay, that's your homework. All right. So is this clear, guys? Does anybody have a question? Does anybody have any question? Okay, if not, I'll move on to the next chapter then. Next chapter is going to be on SOP and POS, and this is going to be a very easy chapter. So if you get any question from SOP POS, you should be able to get full marks in it. Okay, it's a very easy chapter. So before I start it, let me give you an example. So let's have a function. The function is a plus b c bar. Okay, let me use a plus b c bar. So can you guys draw the truth table for me? Truth table for this function. Truth table means first I will draw columns for a b c, and then I'll find the output of f. So I'm giving you guys 2 minutes. Please draw the truth table for this function. Okay, so let's see. So for the truth table, what do we do? First I'll have for A, A, B, C, right? And then I already have a column for A, then I'll make a column for B into C bar. Okay? And then I'll have a column for F. Okay. So how many combinations will I have for ABC for 3 variables?
8.
8. What are they gonna be? 0, 1, 0, 1, 0, 1, 0, 1. And then 0, 0, 1, 1, 0, 0, 1, 1. 0, 0, 0, 0, 1, 1, 1, 1. Okay, 8 combinations. So it's gonna be so there are gonna be 8 combinations. And now let's do B into C bar. So here B is 0, so I don't even have to look at C. Okay, if anything ended with 0, it's gonna be 0. So it's gonna be 0, 0. Here B into C bar will be 1. Guys, is it clear how I'm forming the truth table?
Yes, miss.
Okay. B into C bar, and this is going to be again B into C bar is going to be 0. B into C bar, again B is 0 here, so it's going to be 0, 0. And here B into C bar is going to be 1, and B into C bar is going to be here 0. Okay? Alright, now F is going to be A plus this column. So 0 or 0 is 0. Here it's going to be 0, 1, 0, 1, 1, 1, 1. Is this correct? Did everybody get this?
Yes, miss.
Okay, make sure you have the rows drawn properly. Mine looks very crooked. Okay. Oh, alright. So here I had a function, and from the function I drew the truth table. Okay. Now my question is, suppose I'm giving you the truth table, and from the truth table you have to find a function for me. Okay, so let me take the function away. All this time I had the function and you drew the truth table for me, but now I'm giving you the truth table and you have to draw the function. You have to find out the function for me. Okay, we're going to learn the reverse process. Is this clear, everyone?
Yes, miss.
Okay. Now we're going to learn how to convert, how to find an
Yes. No. How did we get the values for F?
How did we get the values for F?
Yes.
F equals to A plus BC bar. So A or BC bar. And if you're asking me how we got the value without the equation, this is given to you. The truth table will be given to you, and from the truth table, how did they give it? This is the part of the question, like how did you get the function? It was just given to you, right? So if I just give you the truth table, how are we going to convert the truth table to the function? Okay? Okay, so the truth table is given to us, we need to find the function. Now let's see how we can do this. Alright, so now I'm going to discuss about some other things before I teach you how to convert, how to find the equation from the truth table. So okay, now the fact is an equation can be written in two forms. Okay, let's have an equation A plus BC. Okay, the same equation can be written as A plus B and A plus C, right? Using the distributive law. Do we understand this?
Yes, ma'am.
Okay.
Yes, ma'am.
Both the equations are the same, by the way. In terms of simplification, they're both the same. In terms of how simplified they're both the same. And they are both the same equation, but they're in different forms, okay? So every equation can be written in two forms. The two forms are SOP and POS, okay? So SOP means sum of product terms, okay? And POS means product of sum terms, okay? So can you guess which is which?
SOP, that one. Yes.
The first one is SOP or POS?
SOP.
Okay, so the first one is, so now let's see. So suppose I have okay, I'm going to discuss some terms now. A literal means a single letter, okay, a single variable. Like this equation has three literals, okay, A, B, C, okay. Literals are single variables. Terms are when literals are together. The literals can be together by ANDing them or by doing OR with them, okay. So terms can be of two types. Terms can be either product terms, they can either be product terms, or they can be sum terms, okay. So I can combine literals in two ways. Like if I want to write A, B together, this can be a term. A plus B is a term. A and B is also another term, okay. So this is called a product term. When the literals are combined using AND, then it's called a product term. If the literals are combined using OR, they are called sum terms, okay. So in this form, we can see that I have a product of sum terms, okay. So this form is called POS because here I have product of sum terms, and this form is called SOP, okay, because it's a sum of product terms. If you have a single literal, you can consider this as a product term. So A plus BC, BC is a product term. So I have all the, like if I have an equation XY plus WZ, okay, this is an SOP because this is sum of product terms, okay. So any equation can be written as sum of product terms and product of sum terms. For us, it's easier to solve equations that are in SOP, okay. POS, we usually take equations in SOP because that's just easier to solve, okay. But we're going to learn both the formats, okay. So when we have a function, when we have a truth table and you are asked to find the function, you have to choose. Do you find the function in terms of SOP or do you find the functions in terms of POS, okay. So first we're going to learn how to convert how to find the equation from a truth table in the form of SOP, okay. Alright, so we're going to learn how we will find the equation in SOP form, okay. Alright, now for SOP, remember, how do we do SOP? Sum of product terms, right? So we're going to use SOP to find the equation. Oh God. SOP. Okay. So I need to find the equation as the sum of product terms. Now, when we do that, remember that there is a synonym for product term, okay? Product terms are also called mean terms, okay? They are called mean terms. Okay. What are mean terms? So whenever we write a combination, this combination can be represented by using mean terms. Okay. So I'm going to it might sound a bit confusing in the beginning, but just follow me for a bit. Okay, so I'm going to find the mean term. Oh god, this is really hard doing it on the computer.
মিস যে পেন গুলো আছে না ওগুলা তো
I don't have it right now with me, so I'm having to use my mouse. Okay, so now I'm going to write the mean terms. Okay, I'm going to use this column later. Let me so I'm going to write it. Okay. So this combination is called 0. This is 1, 2, 3, 4, 5, 4, 5, 6, 7. Okay, so this is called the zeroth mean term, mean term 0, mean term 1, mean term 2. So with mean term, what we do is we represent this combination in terms of A, B, C. Okay, and mean terms are basically product term. So how do you represent 0, 0, 0? Now the rule is this is mean terms are product terms, so it's going to be product of A, B, C. Now if it's a 0, then you have to write A bar. If A is 1, then you write A. So here, since A, B, C are all 0, the mean term is going to be A bar, B bar, C bar. Okay, so this combination, which is mean term 0, is represented as A bar, B bar, C bar. So if I tell you A bar, B bar, C bar, it means mean term 0. Okay, 0, 0, 0 is represented by A bar, B bar, C bar. So can you tell me what this combination will be represented as?
A bar, B bar, C.
Yes, very good. It's going to be A bar, B bar, C. Okay, this one?
A bar, B, C bar.
Yeah, very good. So now complete the rest of it.
A bar, B, C.
So it's going to be A bar, B, C. It's going to be
A, B bar, C bar.
B bar, C bar. This is going to be
A, B bar, C. A bar, B bar.
no A, B, C.
So A, B, C, C bar. A, B, C, yes. Miss A, B, C, this,
The last one.
yes.
No, last one will be A, B, C.
Yeah, yes.
Last one is going to be A, B, C. Okay, so I've written all the mean terms. Now, if I have to express the equation in terms of SOP, so it's going to be F is going to be, and then we write it like this. F is a function of A, B, C. Okay, so this is how we write it as. So sum of product terms. So we take those product terms for which the output is 1. So for which mean terms is the output 1? For which mean terms? Can you tell me the numbers?
It's number 2. It's A bar, B, C.
Right. So 2, 4, 5, 6, 7. Right?
Yes, miss.
So how do you write it as? So we write it as sum of, this is the sum notation. So sum of, and with small m we denote mean terms. So sum of mean terms will be which terms? 2, 4, 5, 6, 7. Is this clear, guys?
Yes.
Okay, so first I wrote it as, it's a sum of which mean terms? 2, 4, 5, 6, 7. Now this form is known as canonical SOP. Okay, canonical means standard. Canonical or standard SOP. Standard form means when we write it as mean terms of numbers, then this format is known as canonical SOP. Is this clear, guys? This is also a form of an equation. It's called standard SOPs. This is the standard form of writing an equation where we do not use the variables, we do not use the literals, but we use the mean terms. Okay, now let's come to the variables.
So Miss, this summations equation is called canonical
SOP, right?
Sorry, canonical.
Canonical SOP. Okay, now let me write it as in terms of variables. So term 2 is which one? Term 2 is a bar. Term 2 is a bar, b bar, sorry, a
B, C.
a
bar, B, C bar.
A bar, B, C.
A bar, B, C
B,
bar.
C.
C bar, right?
Right, C bar, yes.
Okay, then for number 4,
B bar, C bar.
A,
B bar, C bar.
A, B bar, C bar. Then for 5,
A, B bar, C.
A, B bar, C. Then for 6,
A, B, C bar.
A, B, C bar.
A, B, C. Then the
And
seventh
last is A, B, C.
A,
Okay?
B, C. Yes.
So here we found the equation. But remember which equation did we come from? We came from A plus BC, right? A plus BC bar. How come we did not get A plus BC bar? Exactly. So now you need to simplify to come to the simplified form. Okay. So when you do this, you get the standard form, and notice that in the standard form, every term has all of these 3 variables. Did you notice this?
Yes, miss.
So for standard form, in standard forms, every term has all the variables. Okay. Alright, so can you now simplify this? Can you try simplifying it using Boolean algebra we learned in last class? Simplify this, okay? I'm not going to help you. You should come to this. We already know the answer because I told this to you before, but simplify and you should come to this. Could you guys simplify this?
Yes, we see.
Please let me know if anybody is done. Let me know.
Yeah, the final result must be A plus B C bar, isn't it?
Hmm?
The final result must be A plus B C bar,
Right,
isn't it?
right.
Ma'am, I've done it.
Okay. Rest of you? Did anybody else do it? Okay, let me show you. Okay, so this is another exercise of Boolean simplification. Now let me tell you, if you were asked to find the equation in canonical SOP, then your answer up till this much is fine. Okay, you can just keep your answer up till this much. But if you're asked to find the simplified form of the equation, then you need to write the canonical SOP, then you need to write the equation, and then you need to simplify it. Okay, now for simplification you need to do this a little bit carefully, because sometimes if you do not take the comments properly, then it will cause problems. Then you will be stuck at an equation that is unresolved, but it can be simplified further. Okay, so here I can see that these two terms can be taken as common, right?
Yes,
I
miss.
can take common between these two, so these two terms can be reduced. And then I can also see that these two terms have in common, right?
Yes, miss.
Okay, so these two can be taken as common, these two can be taken as common. How about this term? See, this term can also be taken common with this, right?
Yes, miss.
Okay,
Yes.
so here I have done some analysis, and I see that this term can be used to be taken common with this, and it can also be used to be taken common with this, right? So let's say I have an equation x. Okay, can't I write it as x plus x? Isn't it the same?
Yes, miss.
Right, so what I'll do is I will introduce this term again, and you can do that because this way the equation will still be the same, because 1 or 1 is 1, 0 or 0 is still 0. So if you have the same term, you can introduce it again. Okay, so I'll introduce it again, because this term can be used to simplify this term. So it's going to be a b c bar. Okay, okay, now let's see, let's take these two as common. So if I take what can I take as common over here? A c bar, right? Sorry, b c bar. So if I take b c bar as common, then I get a plus a bar. Okay, so these two have been taken in common. And over here, what can I take as common?
A B bar.
Right, if I take a b bar as common, then what do I get? C plus c bar. And for the last part, if I take a as common, sorry, if I take ab as common, then I get c plus c bar. Okay,
Oh, so you introduced a new term at the end.
yeah,
Okay, got it. Like for the x plus x.
Yeah. I didn't introduce a new term, by the way. I introduced an existing term again. I can't introduce a new term, by the way.
Yeah. Got it.
Okay, I need to introduce, if I want to introduce, I have to introduce an existing term, but it has to be meaningful. The term should be able to reduce another term. Because if I took this two as common, this would have been left alone. Okay, so what do we get? We get BC bar plus AB bar plus AB, right? And then here we get AC bar, and we can take A as common, and then we'll get, wait, did I do this right? Why did I write A here? It's going to be B, right? BC bar.
Ma'am, A common is B plus B prime.
Here I did a mistake, so it's going to be B plus B bar, and then I finally get A plus BC bar. Okay, so this is my simplified form, and this is my canonical SOP form. Is this clear, guys?
Okay, miss.
Okay, so this is how we can find the equation from a truth table, but this is in SOP. Now let's learn how to do it in POS. Okay, so for POS, it means it's going to be product of sum terms. Okay, so product of sum terms means product of sum terms. Okay, so for sum terms there is another synonym. So for product terms it was mean terms. Now sum terms have there is a synonym for sum terms. It's called max terms. Okay, max terms. So max terms are sum terms. So for mean term, where is it? Okay, so for the mean term, this is mean terms for product terms. Now I will find max terms. Okay, now I will find max terms. So for max terms, what I have to do is, max term is basically the complement of mean term. Okay, so if I complement this mean term, what do I get?
A plus B plus C.
A plus B plus C. Okay, another way of writing it is, for 0 we take the variable as it is, and for 1 we will complement it. Okay, and since it's a sum term, we need to sum the literals. So for 0, 0, 0, it's going to be A plus B plus C. So for 0, 0, 1, what is it going to be? For 0, 0, 1, for 0, 0, 1, what is it going to be?
A plus B plus C, right?
Okay, 0, 0, 1. For 0, 0, 1, it's going to be A plus B plus C prime, because for max term it's the opposite. For 0 we take the term as it is, for 1 we take the complement of it. So it's going to be A plus B plus C bar. Okay, now complete the rest of the max terms.
A plus B bar
Yeah, this is going to be A plus B bar plus C.
plus C.
Yeah. A plus B bar plus C. So I'm not going to write the rest of it because it's pretty easy. Just complement the mean term, or you can convert it from the number as well. So 0, 1, 1 will be A plus B bar plus C bar. Okay. So I'm giving you guys 1 minute. Should be able to finish it. Okay, done guys?
Yes.
Okay. Now if I have to write the equation in terms of POS, product of some terms, then first I'll write it as f is equal f of ABC is equal to, so for the notation of product, it's like this, okay? The notation of product looks like this. It's like a pie, but sum was like this, okay? So product of max terms. Now which max terms do I take? So for SOP we took the mean terms where the output was 1, but when it comes to max terms, we will take those max terms for which the output is 0, okay? We will take those max terms for which the output is 0. So for which outputs are the max terms 0?
0, 0, 2 and 3. No, 0, 1 and 3.
0, 1 and 3, right? So which max terms are this? These are 0, 1 and 3, okay? So this is my standard POS. Standard POS, okay? And if I write it in algebra, how is it going to look like? So for 0, it's going to be, 0th max term is going to be A plus B plus C, okay? For 1, it's going to be A 0, 0, 1. So A plus B plus C bar. And for 3, it's going to be 0, 1, 1. So it's going to be A plus B bar plus C bar. Okay? Is this clear, guys?
Yes, miss.
Okay. So now the point is, all these equations are equal, okay? Standard SOP, standard POS, the simplified form, these are all equal, but these are in different forms. So don't think that SOP or POS, a lot of students think that SOP or POS are complements of each other, but it's not. If you simplify this equation, okay, try to simplify this equation at home. If you simplify this, you will get A plus BC bar.
By breaking the brackets.
By breaking the brackets, yeah. But it's, but my suggestion would be, when the equation is in POS, it's very difficult to simplify it, okay?
Yes,
Simplification,
it becomes very like messy.
yeah, it becomes very messy. So if the equation is in SOP, that is easier to solve. Okay, equations that are in SOP. So usually you're asked to give the, but try to solve it. This is going to be a little hard, but it's going to clear out your concepts. But if you solve this, you're going to get A plus BC bar. So every equation can be written in two ways. It can either be written as POS, it can either be written as POS, and it can, oops, sorry, oh god, what happened? Oh, sorry. Yeah, so it can either, oh wow, okay, let's use this. So it can either be written as SOP, or it can either be written as POS. Now the difference between canonical and canonical form is, in canonical form, the terms have all the variables. You see, every term has all the 3 variables. But this is also an SOP, but this is a simplified form, okay? This is not a standard SOP. Because in standard form, every term will have all the literals. But this is a standard POS, this is a standard SOP. Okay? Is this clear, everyone?
So to repeat just for once.
Canonical form means standard form where all the terms have all 3 variables. Like this is SOP, but this is not a standard form because this term does not have BC, this term does not have A.
Right, thank you.
Okay, this is a standard POS because here you have all the terms have the 3 variables, like A plus BC bar. So suppose I have A plus BC bar. This is in SOP. I can write it in POS. How can I write it in POS? A plus B into A plus C bar by doing distributive law. Okay. So this equation and this equation are equal, by the way. Okay. Okay. Because A plus BC bar is the simplified form So A plus BC bar is a simplified form of this equation, and this is the POS form. So this POS and this POS are equal. However, what's the difference? This is more simplified and this is the standard form, because here all the terms have the 3 variables, but here this is a POS. This is a POS, but it's not in its standard form, because in this sum term C is missing, in this sum term B is missing. Is this clear, everyone?
Yes, miss.
So in this example, we learned how to find the canonical SOP, and then we found the simplified version. So if I have the canonical form, I can go to the simplified form.
Miss, in the exam, do you have to do everything like both the simplified?
It will tell you, the question will always tell you that find the standard form or find the simplified form. It will always tell you, okay?
So the simplified form is the one I have to simplify the equation. the expression.
If they ask you to find the simplified form, you need to simplify the expression.
Okay.
Now let's move on to the next part. Here, we're going to do the opposite, okay? In the previous example, we had the canonical form and then we simplified it. Now in the next example, I will give you the simplified form and then you will have to find the canonical form. So here I'm giving you an equation A, B, C. That ABC is equals to A plus BC bar. Now here what you have to do is, I have given you the simplified form. You need to find the canonical SOP for me. Okay, is this clear, guys?
Yes, miss.
Okay, so now we're going to learn the opposite. This is not in its standard form. How do you know that this is not in its standard form?
Since all the terms does not contain the there's no the presence of A, B, C in every of the terms.
Right. So for the standard form, I need to have all the 3 variables in each term. Okay. So now I'm going to show you how we do this. So first to do is, we can write A as A into 1, right? And BC as 1 into BC bar, still the same, right? Guys, right?
Yes, miss.
By the Boolean algebra rules, A and 1 is A, right? 1 and when you add 1 with a variable, the answer is the variable. 1 into 0 is 0, 1 into 1 is 1. So if I have A, I can write as A into 1. Now I can replace the 1 with B plus B bar, right? And here the 1 can be replaced with A plus A bar into BC bar. Is this clear? Is this step clear?
Yes, miss.
Okay. So why did I bring B here?
Because it gives the addition of the complement in itself, it gives a 1.
Yeah, because B plus B bar will give you 1, and I brought B here because I want A to have B and C with it, right? To go to the canonical form.
Oh, yeah, right.
That's why I'm I brought B here, and here I replaced 1 with A because I want the term A with BC bar. Okay. So next I'll have AB plus AB bar. Okay. And here I'll have, if I take the brackets off, I'll have A, B, C bar plus A bar, B C bar. Okay. See, I'm slowly coming to my canonical form. So BC bar now has A with it. Is this clear? I'm actually going to the reverse process. Like when we were simplifying, we took BC bar as common and we eliminated A, right? But here I'm forcefully bringing A. Is this clear, guys? So can you tell me what my next step is going to be?
Trying to bring the other side.
Right. So AB bar here I'm multiplying it with 1. And what do I replace these 1 with?
E plus C bar.
C plus, this one will replace with C plus C bar. C plus C bar. Okay. Okay. This is going to be then AB C bar, ABC plus AB C bar plus AB bar C plus A B bar C bar plus okay, is this clear? Now see, I have come to the standard form.
Yes, miss.
But I still have one step left. Can somebody tell me what?
There is a common part, ABC bar and ABC bar. So this could become ABC bar.
Right. So see, you have. We can eliminate it. AB C bar. See, this has come twice, right? So check again. So this part can be, I can write like x plus x can be written as x, right? So if I have multiple terms that are the same, then I can eliminate it. So ABC bar can be eliminated once. Okay? Because it appeared twice. I have to write it as 1. Now I have written it, but this is still not my standard SOP form. Remember, in your standard SOP form, you do not have any variable, only the mean terms. So you need to write it as like this. This is going to be sum of mean terms. Now which mean terms are these? Guys, which mean terms are this? ABC is which mean term?
2, 4,
ABC?
5.
So for ABC, which mean term is this?
It's from
1, 1, 1, right? Because in mean terms, if the variable is as it is, it's 1, right? So 1, 1, 1 is 7, right? So 7. Then what is this? 1, 1, 0. So this is 6. This is 1, 0, 1 is 5. Then 1, 0, 0 is 4. Then 1, 0. 1, 0, 0 is 4. Then you have 0, 1, 0, which is 2. But remember, you need to reshuffle it, okay? You need to write this in order. So it's going to be sum of which mean terms? 2, 4, 5, 6. Oops. 2, 4, 5, 6, 7. Okay? Is this clear, guys?
Yes, miss.
So now,
Okay, miss.
So see, we have done the reverse process. We had the simplified version, and from the simplified version we went to the canonical form. And in the previous example, we went from the canonical form to the simplified form.
Is it possible to go in the reverse way towards the standard POS form?
Yeah.
From
We're going to learn it next. But is this clear how we go from simplified form to standard SOP?
Yes, miss.
Yeah, miss.
Okay, now we're going to learn the other way where we'll have the simplified form. Okay, we have the simplified form f of a b c. This is a plus bc bar. Now your question is, you need to convert this to canonical POS. Okay, canonical POS. So for this you need to know how to do the for canonical POS, you need to properly know how to implement distributive law. Okay, so first, if I distribute A over BC bar, it's going to be
A plus B.
A plus B, and then
Then the B
A plus
plus A
C.
plus B bar.
A plus C bar, right? Okay. Now next, see what we're gonna do. Can't I write this as a plus b plus 0, and then a plus c bar plus 0? Doesn't this keep the equation the same?
Yes, miss.
Because if I OR with 0, the equation remains the same. Okay, if you see 0 plus a is a. Okay, so 0 plus anything will be the other value. So 0 plus anything will remain the same. Okay. Now what do I replace this 0 with? In this term, what is missing?
C.
So can't I write it like this? A plus b plus c into c bar.
That's good.
Because c into c bar is 0.
Yes, miss.
And what do we write this as?
B into B bar.
B into b bar. Okay. Okay. Next, what do we do?
In using distributive law.
Again, we will use distributive law. We will distribute a plus b over c into c bar. So this might look a little bit confused. So let me remind you how distributive law works. So if you have x plus yz, then you write it as okay. Let's say I have a plus yz. Okay, then I'll write it as a plus y into, no, let me use x. Okay, let me use x, and so it will be x plus y and x plus z. Now let's say instead of x, I have a plus b here. This means this whole part was x, right? So this will mean if I distribute a plus b, oh god, let me write it again. So let's say if I distribute a plus b over yz, it's going to look like a plus b plus y into a plus b plus z. Okay, consider this whole expression as x. So it's going to be x plus y. So x is a plus b, x plus y, and x plus z. Similarly over here, if I have a plus b distributed over c and c bar, it's going to be a plus b plus c into a plus b plus c bar. Is this clear, guys, how I implemented distributive law here?
Yes, miss.
Okay, so be very careful. Consider this as x. So x plus c and x plus c bar, where x is a plus b. Okay, what's the next term going to be?
A plus C bar plus B.
Plus b, and then
And with A plus C bar plus B bar.
and you have, give me a moment, please. A plus C plus B bar.
C bar. A plus C bar
Oh,
plus
sorry,
B bar.
A bar, C bar plus C. Okay. Next, what do we do?
We need to write in the form of the product. So,
Yeah, but before that, be very careful that you need to write this in order. Okay, A, C, B. This is not the right order. Because
yeah.
if you don't write the order like this, you'll get the wrong max term. Okay? So I'll write this in order again. How do you write this in order? A plus B plus C. This is fine. And then A plus B plus C bar. This is fine. Next part is going to be
A plus
A
B bar.
plus B plus C bar, and then
A plus B bar plus C bar.
A plus B bar plus C bar. Okay?
Plus B bar.
Did I do a mistake? Oh right, A plus B bar plus C bar. Okay?
There's a common.
Okay. Is there any common term?
Yes, miss. A plus B plus C bar.
So A plus B plus C bar is common, right? So I can just write it as, I can write it just once. So how do I write it?
Yes, I think there is a mistakenly an addition was placed.
Yeah, sorry. Okay, so these two terms are the same because x into x can be written as x, like it can be written like this. X into x equals to x. Okay, so if you have two terms that are the same, then you can eliminate one. Okay, now I have come to a form where all these terms have the same, all these terms have all the literals, but I'm not done yet. I need to come to the standard standard POS. So how do we do this? I need to find the max terms, right? So for the max terms, what max term is this going to be? So product of the max terms. Max terms are written as capital M, and what are these values going to be? So a plus b plus c. Which max term is this?
0, 0, 0, 0.
Right,
0.
because for max terms, when you have the variable as it is, the variable will hold the value 0. Remember, it was opposite for min term. So if it is as it is, it's going to be 0. So 0, 0, 0. This is going to be 0. And then for this is going to be 0, 0. And if it's a bar, then it's going to be 1. So it's going to be 0, 1. And then this is going to be 0, 1, 1. So it's going to be 3. Okay. So this is my standard POS. Is this clear, everybody?
Yes,
Yes, sir.
Now, do you notice any connection between SOP and POS?
yes, the addition of them or like all the
All the-
values of them.
Right. So if you have the sum of mean terms, the terms that are missing are going to be the product of your max terms. Right? So if you just find SOP, you can very easily find what your max terms are, because the terms that are missing here will be the max terms in your standard POS. Right?
Yes, yes.
And vice versa, if you have your POS and I tell you what is the SOP will be the missing terms in your POS. Okay? But if you're asked to show the algebraic process to find the SOP and POS, then you cannot use the shortcut. Okay? You cannot use the shortcut. You need to do the algebra, but you can use it for checking. Like if you find the SOP and you find the POS and you see that here you got 2, then you know that this 2 cannot be both in SOP and POS. You have done a mistake in either SOP or either POS. Okay? Is this clear, everyone?
Yes, yes, yes.
Okay, so this ends the chapter for SOP POS. This is Amar Kacha. I feel like this is a very easy chapter. It's very straightforward because you will be given an equation and you will be asked find the SOP, find the POS, or I give you the truth table, find SOP, find POS. So I find this pretty straightforward, but your Boolean algebra needs to be good. Otherwise, you can't do these simplifications. Alright guys, so thank you for your time. Our class has come to an end. Does anybody have any question? Acha, okay. Does anybody have any question? If not, I will quickly take your attendance.
ম্যাম আমরা যখন ইকুয়েশনগুলো সলভ করব সাইডে কি মানে লগুলো মেনশন করে দিতে হবে যেটা ইউজ করব
If you're asked to, in the question, then you need to, otherwise you don't have to. Okay? Okay, let me take the attendance. Is my screen visible?
Yes, miss.
All right. Okay, guys. So before this, so when is our midterms?
18 March.
Yeah. So I want to finish the syllabus by next week. I still have one more makeup to take, so I want to take the makeup on Saturday. Does that work for you guys?
Yes, we have 2 quizzes. I have 2 quizzes. Like, we have quiz
Quizzes? Okay, when do you have the quiz?
on Saturday.
Saturday, right? Oh, okay. So I don't want to take the makeup on Sunday because we already have our scheduled class on Sunday. So how about Monday?
Yeah, Monday is fine.
Okay, so I'll take the makeup class on Monday then. But Saturday would have been better because then you have a class on Sunday, you have a class on Monday, you have a class on Tuesday.
মানডেতে আমি আসলে ঢাকা শিফট হচ্ছি আই couldn't able to take that
Okay, all these classes will be recorded, so don't worry. If you miss the class, I will always provide the recording session.